Okay, so we've been looking at the nucleophilic substitution reactions that haloalkanes undergo, and you look here with this blue line. This is all should be all pretty familiar now. If we get bromo, we get bromoethane, and we react it with sodium hydroxide. And this is quite important. This is if you react it with aqueous solution, NaOH in aqueous solution. Right, you end up getting the you get the alcohol and you get the bromide ion, and this is perfectly familiar to us. This is nucleophilic substitution. That's what's happened there. Substitution. And the OH minus has behaved here as a nucleophile. Now, if you do it, if you do it under slightly different conditions, so instead of having the sodium hydroxide in aqueous solution, if you put the NaOH in ethanol, so you've got ethanol as a solvent, alcohol, then what tends to happen is you don't get nucleophilic substitution, you get elimination. You lose HBr, so what happens is you lose the bromine and you lose the hydrogen from the carbon, not the same carbon, but the carbon next door. Okay, and then you form a double bond between those two carbon atoms there. That's what's happening. Okay, so if you instead of using aqueous solution, you get ethanol, you get a different reaction occurring. And here, the OH minus is not behaving as a nucleophile. You see what happens? It's actually behaving as a base. And what bases do, we haven't really done that much about bases yet, is bases, well, acids give away H pluses, so bases accept H pluses. So this OH minus is going to take an H plus, and it actually takes, the H plus from the carbon next door to the bromine, not on the one the bromine is on, the one next door, it takes that, and that we'll have a look at the mechanism in a minute. Now, in actual fact, what happens is when you react sodium hydroxide with a haloalkane, you always get a little bit of both reactions occurring. Okay, you're always going to get both. You never get 100% just one. But you can force it the way you want it to go by choosing the solvent. So if you want nucleophilic substitution, yeah, you would use aqueous solution. On the other hand, if you wanted elimination to occur, then you would use ethanol as a solvent, and you get this one here. So right down there, elimination. You always get a bit of both. So this is a good example of why you're never going to get 100% yield in an organic chemistry or any reaction. Well, and one of the reasons why you get side reactions occurring, you don't just get the reaction that you are interested in. So let's look at the mechanism. Okay, down here. Okay, so we'll start off bromoethane again. Right, and I said I'll put the bromine there. Okay, so the hydroxide ion comes along, and this is acting as a base. Right, OH minus. Now, instead of it attacking this carbon here, it doesn't do that. Okay, what it does is, right, the lone pair forms a bond to this hydrogen here to form water. Now, the pair of electrons in this bond here, all right, there's 2 electrons there. What happens to them is they go to form a pi bond between these 2 carbons, okay? So how would we draw that with a curly arrow? Well, we show the electrons moving from here onto the bond here, right? Now, if that happens, you're going to form a pi bond. So that means that this carbon, I've colored in green, that's going to be forming too many bonds. It's going to be a 5 bonds. So one bond has got to break. And the weakest bond there is the bond between the carbon and the bromine. So that bond breaks. So that pair of electrons goes onto the bromine. Okay, so we've got 3 sets of curly arrows in that mechanism, a lot more complicated than the other one. Okay, so let's see what the product's going to be. Right, so this carbon here, right, it's still got 2 hydrogens attached. The other hydrogen has come off as water, so we'll draw that here like that. Right, so we've got, and then the OH was red, so we'll do it in red. So that's the new water molecule we formed. That carbon is there. We formed a double bond now to that one. That's formed from the pair of electrons that were between the carbon and the hydrogen. And that hydrogen is still there. That hydrogen is still there. And this bromine has come off as Br minus. It's minus because both of the electrons in that bond have gone onto the bromine. Only one of them really belong to the bromine. So that is the elimination mechanism, right? And that is the second mechanism, I suppose, that you need to know. So we need to know the nucleophilic substitution mechanism, and we need to know elimination. And as we said, both of these reactions will occur, really. Oops. Both of these reactions. The one in blue, yeah, that's going to occur when you've got aqueous solution, yeah. And the one in red is going to occur when you have got ethanol as the solvent. Okay, let's leave that there.